So hello everyone, we're gonna do a summary video about the modern CPU architecture. This is Rafael Odrada, your reporter. CPU stands for Central Processing Unit and it is often called the brain of the computer. It can program, can compute, and can process information. The CPU sits at the center of everything in the computer and handles all the computations needed to turn inputs from memory. In short terms, it performs exactly what you want them to do based on your given instructions. Moore's Law. The Moore's Law states that we can double the number of transistors per unit area about every 2 years. This law drives tremendous innovation, making ones we thought impossible to possible. The Moore's Law creates an impact on the evolution of microprocessor. Example of this evolution is the evolution of expansion card slots, where you can see the input and output devices, display drivers, memory, and printer drivers. And these drivers and devices are almost size of a two-hand, and because of evolution, the expansion card slot became smaller but performs almost the same but faster and better than the old expansion card slots. While in the late 1940s, prominent mathematician John von Neumann popularized a new kind of computer architect that simplified computer design and programming. His idea for a stored program reimagined the general-purpose computer as a three-separate system: a bank memory for storing data, an instruction, a central processing unit for decoding and executing instruction, and a set of input and output interfaces. This architecture was so revolutionary that modern computers are still today based on these three principles. In 1959, Robert Noyce patented the first monolith integrated circuit, which combined multiple transistors in a single silicon chip. These early chips didn't have many transistors, but they enabled much smaller and much more complex circuit design. By 1968, several companies were making integrated circuit, and Robert Noyce teamed up with colleague Gordon Moore to get into the game, founding Intel. By 1971, they unveiled the Intel 4004 single-chip microprocessor, and by 1972, Intel released the first 8-bit microprocessor, the Intel 8008. And by 1974, they released 8080, which its CPU design is one of the world's most widespread microprocessors. There are a couple of concepts that are key to understand with regard to computer architecture. First is the binary system, where we use binary numbers for computers to function. Concept of computing abstraction layers. These layers make up computing are well understood and building from one layer to the next, which allows us to build complex computing structures that would be almost impossible to visualize. Instruction set architecture defines what kind of operation can be performed in the hardware. It is sometimes referred to as architecture or computer architecture. Instruction set architecture acts like a sort of a bridge between software and hardware in order to perform. Key building blocks in CPU. You can see that it's what you call the von Neumann cycle, where from fetch, decode, execute, and execute it is either add, subtract, multiply, divide, or logic gates and, or, SOR, NOT, and other branches. And it writes back, which goes to the register and memory. Pipeline depth. The more pipeline stages you have, the faster each stage can run, and the more stages are being done in parallel. Modern microprocessor has around 15 to 20 stages. Fetch and decode stages have typically 6 to 10 stages, and the execute and write back have also grown into roughly 6 to 10 stages. Speculative execution. This is a fundamental component in modern microprocessors for achieving great performance. Front end. refers to the user interface. It is where CPU predicts what instructions are needed, fetches them, and decodes them into micro-operations or UOPs. Backend means the server, application, and database that work behind the scene to deliver information to the user. It is where the decoded UOPs and uses superscalar execution and out-of-order execution to efficiently assign UOPs to execution units. So that's the end of our video. Thank you for listening and watching.